How do I do this? Well, first step is the same. I don't care that this is going to end up being a very difficult problem. The first step's always the same. I find the oxidation numbers. If I look at a guy like CR and I, this could happen. Neither of those guys, in particular for iodine, you see, he's going to change. They're not guaranteed to have any particular oxidation state. Chromium in particular, but even iodine. Given the choice that I've got chromium combined with iodine, who do I want to pick to probably keep as common oxidation state?
Iodine.
Yeah, iodine's further to the edges, probably more likely to keep the octet rule. He's going to want to be a minus one. All right, and if he's a -1, chromium is a very typical +3 for chromium. Peroxide, we're used to seeing them by now. We've seen quite a few of them. Peroxide, H is still +1, but O is -1 instead of -2. Unusual, but that's what happens. CrO4 with a -2. We know O has a -2. Cr must be, well, 4 times -2 is -6. He's going to be -8. But we bring that over and it becomes a +6. All right, it has to be for that one. -2, -8. Bring him over. What's he, +7? Right? Is that correct? Everybody get those. Anybody who tried those get that much at least, because that's not something you should have gotten wrong. Where this one gets difficult is coming up. It's not yet. All right. Chromium's changing. He's going from Cr with a +3 to Cr with a +6. What does it take to do that? Well, there's no subscripts. That's nice. So it's going to take 3 electrons. All right. We call that oxidation. Unfortunately, iodine is also changing, if you didn't notice that. Iodine's got a -1 over here, and he's got a +7 over there. Now, it's a very typical mistake to do what I just did there. What did I not do? I didn't carry the subscripts in. 3 there, so I'll need to balance it for mass first. That's one mistake you can make in this one. Here's a second mistake. 3 times 7 is 21. Plus 21 minus 3. 21 minus 3 is 18, right? 18 electrons? No. Plus 21 and a -3. What's the difference between those? 24. So I need 24 electrons on this side in order for them to both be equal. Now I have a -3 on that side and a -3 on that side. See it? And that's also an oxidation. I have a double oxidation. Many times throughout the last week, people have been asking me, can I just have 2 oxidations or can I have 2 reductions? The answer was always no. Because if you have an oxidation, you must have a reduction. If you have a reduction, you must have an oxidation. Now, this guy does have 2 oxidations, but he must also have a reduction. You can't just have 2 oxidations. And there is. The oxygen in the peroxide is being reduced. O2 with the -1 is becoming, now here's another problem. We've seen this once before. I showed this to you when I did a problem on the board. Watch. It would seem like I would have to put down the subscript of 4 next to my O over here with the -2, but I don't. And the reason for that is simple. I actually have O's with -2 in multiple places on the right-hand side, and actually more than what you think, because there's going to end up being water over here as well. So I'm not saying I'm limited to a 4. I'm saying that the total number of O's on this side are going to be what I'm including in here. Now, it must be some multiple of 2, because this guy, the only place he exists is over there. It must be some multiple of 2. I've got to balance him for mass. But I'm never actually going to use the coefficient that's going to be in front of this guy, because these O's with -2s will be spread out between all of the O's that are over there. All right? So, how many electrons will it take? O to -1, O to -2. Another mistake. What would I do? Put 1 electron. It's not. It's 2 electrons. Okay? That is a reduction. Okay. I now have all my half reactions. They're not really, they're half reactions. The electron equations are written down. But I've got a problem. The total number of electrons lost has to equal the total number of electrons gained. I have 2 electrons gained, but I've got to add up all these electrons that are lost. And that comes out to be, unfortunately, 27. That's unfortunate because it happens to be an odd number, and I can't really make this guy the same number. So what do I have to do here? Anybody have an idea? I can't just change him. If I change just him, it's going to change the iodine as well. That's a problem. You see? Whatever coefficient I put in front of this guy it has to be in front of that guy too. So I've got to change both of these if I'm going to change any of them. And that's what I'm going to have to do. If I have an odd number, want to make it even with an even number, I'm going to have to make the odd number even. And the lowest number I can multiply him by would be 2. But I got to multiply both of them by 2 because look at the 2, if I put in front of the CR, is also in front of the I. You see it? So I've got to put a 2 in front of both. Why does that help me? Because now the total number of electrons lost is what number?
Mrs. Vage right there.
Hurry up.
2 seconds. Excuse me.
What's the total number of electrons? How many? 54. Why is that a better number? Because it's an even number. It goes into 2. What will I have to put in front of this guy? 27. Exactly. Yeah. Ugly number, but that's what you do. Now this now has all my electrons lost equals to all my electrons gained. I'll bring down these coefficients and I'll rewrite it and I'll finish the problem. So what coefficient goes in front of the CRI3? 2. Because it's also in front of the I. What goes in front of the H2O2? What goes in front of the H2O2?
27.
27.
So we're not going to have a problem with this on our actual test.
Absolutely there can be. And there definitely will be one. I'm saying there won't be most of the problems won't be like this. And there's a good chance if I have one like this, it'll be a bonus question. Good chance. All right. However, again, it's possible that it could be a regular problem. You're not going to have a lot of them like this, trust me. All right, what goes in front of the CrO4? Well, you say to yourself, I gotta pay attention to this guy here. All right, I gotta pay attention to that guy for this one. 2 times it. There again, 2 in front of that one. See it? CrO4 minus 2.
Why wouldn't it be 27?
I was just going to get to that. Okay, give me a second. What's the coefficient in front of the iodine? What does the iodine say his coefficient with a +7 should be?
6.
Yeah, 2 times 3 is 6. 6 IO4s. All right? Now the question is, why am I not using the 27? Well, if you remember a minute ago, I said you'll never use this coefficient that goes in front of this guy. Why? Because it's actually, doesn't mean that I have to have 27 times 2, 54, as a coefficient in front of an O with a -2. It means I have to have 54 O's with the -2 on this side of the equation. And that's the difference. In these cases, I only have chromium in one place. If that coefficient of 2 has to be in front of that guy, that's what it's got to be. There's no coefficient of 54 ever going to be used. It just means I've got to have 54s with O's with a -2. That's how many I need on that side. And they're going to be split up between some of them here, some of them here, and some of them maybe even in the water, which we're going to have to add on right now. All right, so I am done. And you have all but 1 point now on the last part of the problem. And this was a particularly hard one to get all those points. A lot of mistakes you could have made in here. But you're there. You got 1 point left. You're going to use the balancing of the charge and waters and OHs to help you out. Because this is a basic solution, it said, you can add water or OH to either side, wherever you want. Let's see what I'm going to need. 2 times -2 is a -4. 6 times -1 is a -6. I have a -10 on that side. I can add OH minuses, OH negatives. What side will they have to go, and how many will I need?
That's on the right side.
Not the right side. If I put them on the right side, I'm going to have OH minus, I'll have -20 over there and 0 over here. I'm going to need 10 OHs here. And what do I have to be careful of when I write that? What does that look like now? 100 H's. Make sure you put parentheses around that. Okay, I'm still not done. I got to check out my oxygens and hydrogens. The easier one probably to look at would be the hydrogens. It's a little bit fewer places, although really, actually not really. I got 10 hydrogens here. 27 times 2 is 54 hydrogens. There, it's 64 hydrogens. What will I need for waters over here? 32 waters. And now it's finally balanced. Now, again, saying it again so you don't panic. The vast majority of problems won't be this hard. Chances are if you see one like this on a test, it'll probably be bonus. One like this will be bonus. All right? And you won't see more than one this hard in the test, period. Okay? That isn't just a bonus question. All right, good enough. You know what to do now. Finish the rest of that worksheet, number 3.